And we're moving on to Unit 8, Lesson 1. This is solving linear systems by graphing. And your objective is to solve a system of linear equations by graphing. Alright, so let's jump right into it. A couple definitions here. A system of linear equations, or a linear system, includes two or more equations. Okay, so for example, this right here forms a linear system where we got one equation and another equation. Okay, we could have 3 equations, 4 equations, but for right now we'll be dealing with 2 equations. Right, the solution of a system of linear equations is the ordered pair that is a solution of each equation. So for example, in the above equations here, the ordered pair 3, 1 is a solution to each one, okay, each equation. And we can prove this by plugging it in. So if I go, whoops, let me get my other pen here. If I go x plus 2y equals 5. If I plug 3 in for x and 1 in for y, then it should work for each equation. Okay, so we get 3 plus 2, and we get 5 is equal to 5. Okay, so it works for that equation. Now let's try the other one. We'll plug in 3 for x, and then 1 for y. Oops, sorry, I should say equals 3. And solve it and see if it works. Well, 2 times 3 is 6, 3 times 1 is 3, and 3 equals 3. So this ordered pair works for both equations. Okay, it is a solution to each one, so that means it's a solution to the system as well. Okay, so our goal on these to solve systems of equations is to find the ordered pair that will be a solution of each one. And our first method we're going to find to do that is graphing. Okay, and we have a couple different methods, but we're going to do graphing first. So let's go into some examples. Okay, this example says to use the graph to solve the system of linear equations. Then check your solution algebraically. So this is the linear system. Here's our 2 equations. And the lines have already been graphed. So my 3x plus 2y equals 4 line is right here in blue. And my negative x plus 3y equals 5 line is right here in red. Okay, so it's already graphed for us. And easy enough, once we've got the lines graphed, the nice thing about the graphing method is it's visual and you can see what ordered pair is the solution to both of them. And the solution is the ordered pair where the graphs intersect each other. So it's this point right here where they cross. Okay, we'll put this in green. So that's the point where they cross, so that ordered pair. And again, when we graph, we're going to approximate it, okay? So this one happened to cross right on the grid line. So that's going to be at 2 and negative 1. Okay, that's the ordered pair where it crosses, or where they cross each other. Now we can check this algebraically, see if it works. So I can plug this into both equations just to see. So if I do 3 times 2 plus 2 times negative 1, okay, in place of 3 times x and 2 times y, I want to know, does that equal 4 or not? Well, this is 6 plus 2 times negative 1 is negative 2. And, of course, 6 plus negative 2 is 4, which equals 4, so it checks out. Okay, now we got to try the other one. This is the opposite of my x, so it's the opposite of 2, or negative 2, plus 3 times my y, which is negative 1, equals negative 5. So we get negative 2 plus 3 times negative 1 is negative 3, and it works. Okay, so this is the solution to the equation. And this down here is how I check it algebraically. If you're told to check it algebraically, you need to make sure you show this works. So plug it into both equations and solve them down. Okay, and yes, solve them step by step like I did. Don't take any shortcuts. Alright? So let's go on to some steps and an example of how to start from the graphing aspect and actually do the graphing yourself. Okay, here are our steps to solve a linear system by graphing. The first thing you're going to do is write each equation in a form that's easy to graph. So it might be slope-intercept form, it might be point-slope form. You might just leave it in standard form and use the little tricks I taught you, okay, to solve this. It kind of depends on what you like the best. And that's what I would do, is we learned slope-intercept, point-slope, and standard. I would use the one that you like the best for graphing and write it in that form. Okay, then step 2. is to graph both equations in the same coordinate plane. So I'm going to graph one of the lines and then graph the other line, both on the same coordinate plane. Step 3 is to estimate the coordinate of the point of intersection and write that as an ordered pair. And this is the solution to the system. So the point where the lines cross, if it crosses in the middle like 3.5 or something, you can estimate that. Okay? So we're going to estimate the point of intersection, where the lines cross each other. And then step 4 is to check the solution by substituting the coordinates into each equation of the original system, is what that should say. Okay? So each equation of the original system, we plug it into both of them because the solution has to work for both of them. Okay, now if you get like a half or something like that, it may not come out quite even, but if it's really close when you have to estimate it, then that's okay. Alright, so let's do a full example here. Okay, so this example says to solve the system graphically and check your answer algebraically. So again, the first thing we want to do is get these in forms that are easy to graph. So I'm going to do my first line here in blue, and I'm just going to rewrite this. X plus y equals -2. Now this is already really close to slope-intercept form, make it nice and easy to graph. So I'm going to convert it to slope-intercept form. Okay, and that gives me y equals -x plus -2. And then I can go ahead and graph that line. So I'm going to go to -2 and put my dot there. My slope is down 1, back 1. Down 1, back 1. Okay? And that's going to run right along here. And I want to extend this line as far as possible. Okay, just to make sure I know where they're going to cross each other. So there's my first line. Now my second line, I'll do that in red. Okay, this one's going to take a little work to get to slope-intercept form. It's not point-slope form. So I'm going to go ahead and use my tricks for standard form I learned. Okay, my tricks for standard form, I know my slope is the opposite of A over B. Okay, well the first thing we can do is change this to adding the opposite, so it's plus -3y. Well, the opposite of A is -2, and B is -3, so my slope is 2 over 3, because negative divided by negative is a positive. Then my y-intercept, if I remember, that is C over B, remembering my tricks. Okay, so that's -9 over -3, which is positive 3. So I know my slope is 2/3, and my y-intercept is 3. So I'm going to use those. Okay, we'll put my dot here at 3. My slope is 2/3, so I can go up 2 and over 3. I can also go back, or down 2 and back 3. Okay, and now my line, this one I can tell where they cross already, so I don't need to make it quite as big. Okay, and they cross right here. Okay, and that ordered pair where they cross should be my solution. So that is at -3 and +1. Should be where they cross. Well, now I need to check this algebraically, so I'm going to check it by plugging it into my original equations. So I'm going to plug it into my x plus y equals -2 equation. And instead of x, I'm going to put -3. And instead of y, I'm going to put 1. And -3 plus 1 does equal -2. So it works for the first equation. Then I'm going to plug it into the second equation. 2x plus -3y equals -9. And instead of x, I'm going to put in -3. And instead of y, I'm going to put in 1. And see if it works. Well, 2 times -3 is -6. -3 times 1 is -3. And -6 plus -3 does equal -9. Okay, and it checks out like it's supposed to. So that means that my solution is correct right here. -3, +1 does work. That means my graphing was correct and everything else. Okay, so make sure you don't skip the checking part. Okay, you should always check these to make sure that you didn't do some math wrong. Alright, so again, don't skip any steps on this. And let's go to one last example. Alright, so here's a word problem. We've got the song Locked Out of Heaven by Bruno Mars is currently number 4 on the Billboard Hot 100. The song I Will Wait by Mumford & Sons is currently number 36. And Bruno Mars slips an average of 4 spots per week, and Mumford & Sons goes up an average of 4 spots per week. how long will it be before they meet on the chart? So we solved a problem like this once by setting them equal to each other and solving with variables on both sides. We can also solve this problem visually with a graph. Okay, so what I'm going to do is I'm going to make my x value equal to the number of weeks there on the chart. And my y value is going to be equal to their spot. Okay, well if I'm going to write this equation here, let's see, we'll do Bruno Mars in blue. He's currently number 4. So after 0 weeks, he's at 4. So that's his y-intercept. That's his b. Okay? So we're going to have our y, our spot on the chart, equal to something plus our b is 4. And our slope, we know that he slips an average of 4 spots per week. Remember, on the Billboard charts, slipping means that your number is actually going upward. Okay, so if he's slipping, that means he's going toward 100 from number 4. So his number's getting bigger. And if it's 4 spots per week, his slope has to be 4 times x. Okay, and again, it's a positive 4 because slipping means his number is actually going higher. Okay, so 4 times the number of weeks plus his starting spot should equal his spot on the charts. Likewise, for Mumford & Sons, we'll do them in red. Their spot on the chart, okay, it's currently number 36, so they're starting at positive 36. And then they're going up the charts an average of 4 spots per week. Okay, which means their number's getting lower, so their slope needs to be a negative slope. Because their number's getting lower every single week. Okay? Well, we got both of our equations, now we need to graph. Well, if I look at my y-intercepts, 4 and 36, 4 goes into 36, so that means that my scale on my y-axis should probably be by 4s. So I'm going to count by 4s on the y-axis. So 4, 8, 12, 16, and so on. On the x-axis, I can probably get away with counting by 1 still, so this is going to be 1, 2, 3, and so on. Okay, then we can graph these. Well, Bruno Mars' spot starts at 4, so that's 0 and 4. Okay, then his slope is up 4 over 1. Well, if I count my y-axis up 4, that's really just up 1 spot. And then over 1, a run of 1 is still over 1 spot. So my line is going like this. Okay, and it's only going in one direction because we can't have negative numbers for our slope. Or we can't have negative numbers for our spot, so we can't go in this region, so it's only going that way. Alright, now Mumford & Sons, its spot's 36. Well, that's going to be up 9 on my y-axis because I'm counting by 4s, so that's going to be right here. And it's going down 4 over 1, so that's going to look like this because I'm counting by 4s on the axis. And sorry, my graph's a little off here, but you get the idea. So this right here is the spot of intersection. Okay, so we need to figure out what that is. Well, that's over 1, 2, 3, 4 on my x-axis. It means I'm counting by 1s. That's just a positive 4. Okay, so that's the number of weeks it's going to take them to pass, because that's what my x was for. And the spot they're going to be at is on the y-axis. And I'm counting by 4s, so that's up 4, 8, 12, 16, 20. So they're going to pass at spot 20. Well, that's where they're going to meet. So after 4 weeks, they should both be at spot 20. And now, of course, we need to check this in each equation. So for my blue equation, y equals 4x plus 4. We're going to see if it works out. I plug in 20 for y and 4 for x. 20 equals 16 plus 4. And that checks out. Likewise, if I plug it in for the red equation here, I get 20 equals negative 4 times 4 plus 36. That's 20 equals negative 16 plus 36, and 20 equals 20. So it checks out in both equations, so we're good to go. Okay, so how long will it be before they meet? That was our x value, the number of weeks. So my answer is 4 weeks. And that's your lesson on graphing systems of linear equations. If you have any questions, ask. Otherwise, good luck on the homework and happy graphing.